let's try another proof. So it's given that A is parallel to B, and we want to prove that angle 1 and angle 8 are supplementary. So it's given that A is parallel to B. Now let's come up with a plan of action here. Well, 1 is here and 8 is here. A is parallel to B, and it's being cut by this transversal. Well, we know that angle 1 and angle 5 are corresponding angles. Because parallel lines cut by a transversal form corresponding angles. Then we can state that they're congruent because if lines are parallel, corresponding angles are congruent. Well, we're going to be working with supplementary angles, angle 5 and angle 8. So we're going to be working with addition and an equal sign. So I'm going to change this to the measure of angle 1 equals the measure of angle 5. That way we can say that two congruent angles have equal measures. Now, we want to somehow get that angle 1 is supplementary to angle 8. Well, we know that 5 is supplementary to 8, but we know that because we can see that this is a line, and we can see that 5 and 8 are a linear pair. So first we have to state that they're a linear pair. The reasoning for this is something along the lines of adjacent angles whose sum is a straight angle are a linear pair. Since they're a linear pair, we can then state that they're supplementary. Because angles that form a linear pair are supplementary. Which means that the measure of angle 5 plus the measure of angle 8 is 180 degrees. Because supplementary angles add up to 180 degrees. Now using substitution, since the measure of angle 1 equals the measure of angle 5, instead of the measure of angle 5 here, I'm going to write it as the measure of angle 1 plus the measure of angle 8 is 180 degrees using substitution property. And finally, we can state that angle 1 and angle 8 are supplementary because if two angles sum to 180 degrees, they're supplementary. And this would be the end of our proof here. Here we have the exterior angles theorem. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. So angle 1 and angle 7 are congruent, and angle 2 and angle 8 are congruent. So copy the theorem, the diagram, and then the examples. So let's use this algebraic example. We want to find the measure of value y. Well, by looking at the diagram, we see that, let's say this is line L and this is line M. L is parallel to M. Let's say this is transversal T and this is transversal S. Well, if we're looking at transversal S, we can see that this angle is congruent to this angle because they're corresponding, which means this angle must be 80 degrees. We can also see that this angle is congruent to this angle because they're corresponding, which means that 40 plus y must be equal to whatever this angle here is. Well, if the measure of this angle was 80, and these two angles are supplementary, that means that the measure of this bottom angle must be 100 degrees. So 40 plus y must equal 100 degrees, which means that y must equal 60 degrees. Now there's a few different ways that we can do this. We could also look at it as instead of looking at line S, transversal S, we can look at transversal T. Well, by looking at transversal T, we can see that this angle and this angle are alternate interior, so they must be congruent. And if we extended this line out this way, we could see that this angle and this angle, the whole angle, don't pay attention to S, the whole angle are congruent. Well, if this angle is 40 degrees, then this angle must be 140 degrees, which means that this whole angle must be 140 degrees. But what we know from looking at transversal S, this angle is congruent to this angle because they're alternate interior. So that piece is 80, which means we're left with 60 degrees. So y, again, is 60 degrees. So there's multiple ways that you can solve this, many different ways that you can look at it, but those are a few.